All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be taking a very brief look at the Hugging Face Transformers library again. This is, I don't know, this is probably like the second or third time probably that I'm relearning this library. In the past, I've explored this library a little here, a little bit there. I didn't go too deep into it, even though I was trying to, but I ended up getting distracted with other stuff. But I did get a chance to explore the library to a certain extent, to where I know that the library is structured in a way that makes it easier for you to use various models after they've been implemented by the library, of course, or implemented in the library. But yeah, anyways, the library is structured in such a way that it's meant to make it easier for you to use these models. It's meant to give you a sort of seamless API experience for using various different types of models, and it groups these models and the various moving parts into a fixed number of groups. So once you know about these fixed number of groups, you can kind of like you can easily mix and match them. But also, if you don't want to have to deal with all the moving parts of a specific task, then you can use one of their even higher level concepts called pipelines, where you just give it I believe you just give it the model name, and after that you can just pass in your input and get your output. It's that simple. They've designed the library in a great way to make it super easy for you to just get started with using a bunch of different models. Whereas in other cases, if you want to try and use some of the individual models, there tends to be, or they used to tend to be, a bit of a setup required before you could actually start using the model. Now, all that being said, I haven't touched transformers in a while, so recently I wanted to get back into it. I kind of okay. So I'm going to be doing the Hugging Face LLM course, which introduces you to not only Hugging Face transformers but other libraries within this ecosystem, like their datasets library, tokenizers, and a couple of other libraries. Sorry, give me a second. Yeah, what was I saying? Yeah, so it introduces you to a bunch of different um, it introduces you to a bunch of the different libraries in the ecosystem. But at the moment, I don't have time to go through the entire LLM course, and I want to get like a quick primer on the Hugging Face Transformers library. I already kind of know the basics of it, but I just want to get all the basics down. Just I want to get like a very quick intro to transformers, just so I know about all the various moving parts that are involved, because I know about the pipelines thing, right? That's a very high level concept. If you want to have a little more control, then you can use for how do I say this? For separate tasks, they have different types of components available, or different types of namespaces where you can like load up uh, the models. So, for example, for a large language model, you would have first the tokenizer, and then you would have the large language model. So they have two separate like components to help you load these two separate things, and then you can like customize their input and output, or you can do any sort of processing that you need to do in between steps, or before steps, or after steps, or whatever. There's a bit more fine control that you get when you do it in this way. However, you don't always need to, you know, customize things. Sometimes you just want to use the model as it's meant to be used, and so then you can just use the pipelines API. So I know at least that much. I guess I would say I know a fair bit about transformers, but I want to get a better idea of all the moving parts of transformers, just so I can get started with working on my auto clipper script. Sorry, I got distracted. What was I saying? Yeah, so I wanna get an idea of all the moving parts. So what I'm gonna do here is I'm yeah, okay. So first off, let me change the model to just Flash should be fine, I think. Okay. I want to learn. I've noticed this thing. I don't know what's going on with my mouth, but I tend to like um, do clicks a lot, like that kind of thing, unintentionally when I'm about to start talking, and it sounds kind of weird. Um, Mostly because if I was talking to somebody and I did that, and there was that click sound at the beginning, it would kind of sound like I'm annoyed when I'm talking to them, or I'm annoyed at something that they said, or yeah, that's just a random thought that I had. Anyways, I want to learn about the HF Transformers library. Man, I started the stream really late today. I was supposed to start the stream, believe it or not, 2 hours ago, and then because of X reason, and then Y reason, and then Z reason, it just kept on getting delayed. And these reasons didn't these weren't even like important reasons. The the stream didn't need to get delayed, but yeah, it is what it is. Also, I was doing some research yesterday on microphones. Well, okay, I was doing research through Gemini on the audio quality that I would be able to achieve. Give me a second. Just a second. Okay. So, yeah, I was doing research on the audio quality that I would be able to achieve if I were to bring, if I not bring, if I were to build a microphone using using a mic module, an ESP32, and maybe an extra ESP32 for doing DSP, digital signal processing. So I was doing research on this, and through that, I found out that the specific module that I was planning on buying is that's actually a bad idea. I should be going for another one. So, okay, the one that I was planning on buying was a Max something. It was hold on, let me get the exact name so I can tell you guys. Just a second. Hold on. I'm just doing something in the background. Okay, what was what was I gonna do? Yeah, Max. Um, no, mic module, Max. Yeah, so what I was going to buy was either a Max 9814 module or a Max 4466. I think it was a 9814. I don't remember. Um, what was I saying? Yeah, so it turns out that this specific module is not good if you are trying to build um, this specific module is not good if you're trying to build a microphone for, clarity. Like if you actually want to have good quality recordings, it's great build if you're trying to build it for like very low quality purposes, like where quality is not going to matter. So it can sound like a walkie-talkie, or it can sound, not that great. It can have various types of like noise in it, and it wouldn't be too much of a problem. Like for example, if I wanted to build a simple mic that can capture my audio and then feed it into a TTS model, so that can then be, you know, transcribed to text. And wait, that's not a TTS, that's a STT model. Yeah, so basically, I can use a speech to text model to convert that very low quality audio into text. Because I'm feeding it into a speech to text model, the audio quality is not gonna matter as long as the model is able to still pick up the details that it's supposed to pick up. So to a certain extent, the audio quality will matter, but what I mean is the audio being crystal clear is not nearly as important. Okay, all that being said, because I'm trying to build a mic that would have good quality, or at least, that's a sort of experiment that I'm trying to do. Instead, what was recommended was using what is it? INP, I think? INF, INB, INMP. That's what it is. So one of the differences between both of these modules that Gemini told me about is that with the Max 9814, what it outputs is analog signals. Those analog signals get fed into, and they might not be very high quality analog signals to begin with, but like what happens is the mic picks up the sound and converts it to like a very small signal, and then there's some kind of boosting circuitry that boosts that signal, so it can then be sent out as output from the module, and it can be read in the ESP32 or whatever microcontroller through an ADC, through an analog digital converter. So the important thing here is that what's being sent out is an analog signal, and what's being received is what's being sent out is an analog signal, and what's being received by the microcontroller is an analog signal that then has to be converted to digital. So depending on your microcontroller's ADC's quality and how well it handles the received audio signal, your whatever you're receiving from the mic is going to be dependent on that. And apparently, the ESP32 tends to have a lot of noise when it comes to analog signals due to various things within the ESP32 itself, like RF related circuitry and a bunch of other things. So there can be a lot of noise in the analog signal, and that can kind of ruin the quality of your audio. So with INMP 441, apparently there's already an ADC on that chip. So all of the whatever processing has to be done from analog to digital, it's already being done on that chip. And then the data is being fed from that chip, or it's being sent from that chip to the microcontroller, as digital data, not as analog data. So it's a digital signal that's being sent, not an analog signal. And at least based on what Gemini was saying, it tends to be a 24-bit signal, which is great. As in the bit depth of the data tends to be 24-bit. I'm not sure though. So let me just confirm that. But yeah, this is one of the differences between these two. And that's also one of the reasons why you would probably get a better audio quality. Maybe not as good as, um, a dedicated microphone connected to a dedicated audio interface. Maybe not as good as that. Maybe not even as good as a Blue Yeti. But you'll get okay, okay sort of audio quality. And of course, after that, I'm planning on applying. After that, I'm planning on applying various DSP operations to it, various DSP filters and stuff to further clean up and polish the signal. Actually, I should check if, because I think the DSP would be done on the digital data, right? Because the DSP is being done by the CPU. So this has to be done on digital data, not on the analog data. Okay, yeah, yeah. So looking at looking at a block diagram of INMP 441, what I'm seeing here is we have the mic. The mic is connected to an ADC. So the ADC is outputting digital data, and then that gets passed through some kind of filter. I have to see what the filter is doing, or maybe we are able to program that filter to do something. I'm not sure because there is something to control the hardware. Yeah, and then after that, it gets passed to the serial communication block, which is I think I2S. I'm not sure. So yeah, I think I definitely dodged a bullet by not buying the Max 9814 and instead going with this one. I'm hoping that when I buy this, I'm gonna get um, better audio quality. Now I need to see what the bit depth is. Oh yeah, it says it has an industry standard 24-bit I2S interface. The I2S interface allows the INMP 441 to connect directly to the digital processors, such as DSPs and microcontrollers, without the need for an audio codec in the system. All right, okay, you know what? That's good enough for me. So I'm excited for this project because I do have a couple of ESP32s lying around, so I would love to run this experiment that I've been planning on doing. I want to do some of the DSP on the ESP32 that's receiving the audio, and then some extra DSP on another ESP32, and I want to bridge both of these ESP32s together using a parallel data bus. So we'll have parallel communication instead of serial communication, and hopefully that should be much faster as well than just serial communication. So we should have much lower latency. Now, another thing that could affect the latency is how long it takes for the data to go from the microcontroller to the PC. So that's going to be another thing that I need to look at, but like we can, take that step by step. Anyways, now let's continue with this. Give me a second here. Just a second. Okay. All right. Let's continue with this. Okay. Right. I want to learn about about the HF Transformers library. I'm gonna eventually go through, spelled through wrong, go through the HF LLM course, which, if I understand correctly, uh, introduces you to not just transformers, but the other libraries in the ecosystem as well. And that's great, but I don't have the time to go through um, that entire course right now. So what I want to do is get so what I want to do is get um, what should I call it? Because I don't want to call it a primer. I want to okay. What I want to do is get um, information about the transformers. So with this prompt, I'm going under the assumption, or I'm telling Gemini that I don't know anything about transformers. So, teach me keeping that in mind. I think because I'm doing this through Gemini CLI, I should also mention don't take any write actions. Just give me the information here. I should also mention don't write anything into an MD file because there's within this directory there's a bunch of MD files. Hold on, I think I can show you guys if I'm yeah, here. There's a bunch of files here. And like most of these were generated by Gemini. One of actually a couple of these were when I was trying to learn about waves, the general concept of waves and how they work. Um, in fact, I need to stitch these things together. I need to stitch this information together to put onto my website, which I never finished learning about Zola, dude. Holy shit. I need to finish learning about Zola so I should probably add that to the list. Let's see, where can I do this? Was it here? I don't think it was here. Huh. Okay, let's go into documents. Oh, this documents. There you go. And open up HMM. I need to be careful with the tab here. New year 2026.HMM. Right. So, what was I gonna? Oh, yeah, home lab, and then website. Why did I, why did I write it like that? Rust and Zola. Yeah, I don't think I'm gonna be touching. I don't think I'm gonna be touching WASM for now. I just wanna get the website up and going, and I need to write a couple of things to be able to automate the process of converting my Gemini conversations into something that can be posted onto the website. I'm also going to need to find a way to kind of streamline the process. I have no idea how I'm going to go about doing that. maybe I could set up a sort of diffing mechanism where every now and then, once I have a bunch of extra entries or extra data like this, because there's two things that I have to look into. One is my journal entries, uh, which are random bits of knowledge that I've learned, and I wanted to save them and write them down just for my future reference. But then I also want to I also want to share it with other people because this information can help other people in the future. Because like if I've had that issue, then there's definitely going to be other people who have had a similar issue. And so if you know whatever little bits of information I'm sharing, if they can help somebody solve their problem, then you know that's great. So that's why I want to share the information online. So there's going to be my journal, the entire like TUI journal thing that I have. That's going to be one, basically my knowledge base that I've created within TUI journal. I need to write a tool to parse all of that and convert it into something that can be posted onto my website. Uh, but oh, okay, yeah, sorry, I lost my train of thought for a second. Yeah, so that's one thing of the knowledge base, but then another part of the knowledge base is the Gemini conversations that I'm having. And I want to make these two separate things. I want to make it clear that in one case I've written all of those journal entries, and in the other case, those are conversations that I had with Gemini, and I'm sharing the conversations so people can learn from them. Now I need to find a better way to display this data, um, while also having it be optimized for SEO. And unfortunately, like the data has to be on the page somewhere in the page's metadata, even if it's not like visible, it has to be somewhere in the page's metadata in order for it to be seen by uh, whatever search engine or whatever. In order for it to have good SEO, it should that data should exist on the page so it can be kind of seen by the search engine. So I need to find a way to go about that because all of these conversations that I'm having and the various journal entries that I have, what I was planning on doing is making all of them separate pages. That would be incredibly simple to do, mostly because I'm going to be writing tools that automate the process of creating these kinds of things. So even if it's like 20, 30, 40 files that are created, like 40 separate pages that are created, it's not going to be an issue because it's all being generated by a tool anyways, right? I need to see how much of a headache it would be to upload or re-upload such a site. I don't think I would be re-uploading each time. What I do have in mind is one idea that I have is I want to create a sort of diffing feature. I'll have to see what's a good way to set up the diffing mechanism. But I do want to set up a diffing mechanism. So, for example, if I had 10 or 20 entries in if I had 10 or 20 entries in my knowledge base and I converted them to web pages and they have now been uploaded to the website, right? There's going to be a directory in which these pages are. So the tool that's doing the conversion, it's supposed to drop the pages directly in that directory. So before I do the conversion, once all of this data has been read, then there I can create a diffing tool that calculates or processes the data and then yeah calculates is the best way to put it. It calculates um, exactly which files are going to be created, and then it can check the directory to see if those files exist. So if the files exist, then those files don't need to be copied. But the files that don't exist, those files need to be copied. And then from the website's point of view, because the website is it's a GitHub website, it's a GitHub repo. From the website's point of view, it's just going to look like, hey, there's a couple of new files that have been added in here. Something else I'm going to need to do is this is going to be a bit of an undertaking because I'm going to have to make sure that my website or my tools are able to write the data into a Zola web page using the Zola language, or in this case, whatever the templating language is. No, the templating thing doesn't have its own language. There's an engine that is a templating engine, but I guess Zola dictates what the templating language would be. I don't know. I'm going to have to explore all that again. I don't remember. There's a templating engine that handles the actual like parsing of the template data and stuff. And yeah, I'm going to need to make sure that whatever data I'm writing, it also, has this Zola related metadata in it. That being said, I'm not expecting the websites to look, really great, but I'm also going to be using I'm going to be using other people's themes. I might start out the website as just bare bones. I'm curious to see how well that works out. I just want to start out the website as a bare bones website, and then apply a theme to it and see how well the theme fits. I do have a couple of themes that I liked on the Zola website, because the Zola website does also showcase themes that were made by the community. Okay, dude, enough of this. Let's close this and go back to this. Holy shit, dude, how long? It's been half an hour. Okay, I mean that's not that bad. So what I want to do is get information about the Transformers library to understand all the moving parts in it so I can get started with it real quick. And then later, when I have time, I can go through the LLM course. I also want to mention that I'm not just, no, hold on. I'm not using HF transformers for just LLMs. I'm I want to learn about HF transformers in general. Also, kindly do not take any. I wonder, dude, okay, I'm wondering because the model it has been specifically here in this case in the case of Gemini CLI. I don't know if it's just a learned behavior in the model because it noticed that I like to have things written to a file, or sometimes I add the command to just export the data to a markdown file. So I don't know if it's because of that Gemini automatically just jumps to recommending writing it to an MD file so I can then read it, or if it's some sort of optimization that's that's causing Gemini to suggest writing it to a file rather than printing it out to this chat. I don't know if that's some kind of optimization technique. I can't see how that would be an optimization technique because the data has to be printed out anyways, whether it's being printed out in this CLI or into a file. It's the same thing, isn't it? I mean, there's minor differences here and there, but like it's I think the token generation would be the same. So I would have to assume that it's probably because of um, I would have to say it's probably because of shit. I lost my train of thought. Anyways, um, in general, okay. Also, kindly do not take any right actions. If I need you to write something to a file, I'll ask. Um, just put the info in this. No, just print out the info here. Was there anything more I needed to add? Okay, while this response is being generated, we can go to my browser. Let me just make sure you guys are able to see everything. Okay, so you're able to see this here. Um, you're able to see this here. And now we're going to open this, Transformers. Oh, there's the information. All right, never mind then. Let's read. Oh wait, it's getting broken. It's getting broken up. Hold on. Can we scroll? Okay, there it is. Great, awesome. So, Hugging Face Transformers. The Hugging Face Transformers library is a powerful and versatile tool for working with state-of-the-art pre-trained models. It provides a unified API for a wide range of tasks across different modalities such as text, vision, audio, etc. Here's a breakdown of its core components and how they fit together. Okay, core components of the HF Transformers library. First is models, auto model and pre-trained model. Purpose. This is the actual pre-trained neural network architecture. These are the actual pre-trained neural network architectures. Example, BERT, GPT, T5, Vision Transformers, Wave to VEC, etc. They encapsulate the model's layers and parameters. This is reminding me that I need to go back to that conversation that I was having with Gemini about GUF, the GGUF, and some of the information surrounding how architectures are defined within this format, because this is a GUF is a common thing that you'll notice, at least these days, when LLMs are being mentioned. This is apparently a format that you can use to store LLMs, I guess you can say. You store both the model architecture and the weights, if I remember right. There's within within the format itself, you are able to define the architecture of the neural network or something along those lines. I don't remember. I'm gonna have to go back and read that entire thing because I didn't fully finish reading that. I had a couple of other questions, and after that, I had some technical issues because of which I had to close the conversation. But yeah, okay, let's continue with this. So, a pre-trained model, the base class for all models, providing common methods like loading pre-trained weights, saving models, and managing configurations. Auto model, a very convenient class that allows you to load any model from the Hugging Face model hub by simply specifying its name. Just a second. Hold on. Just a minute. Sorry, I got very distracted with something. All right. Okay. Wait, are we not live? Oh no, it's just yeah, no, we're words. We are good. Holy shit, I got stuck in a loop. Okay, let me close this and open it up again, and then we can continue reading. Okay, so auto model, a very convenient class that allows you to load any model from the Hugging Face model hub by simply specifying its name. It automatically infers the correct model architecture. There are specialized model classes for different tasks like auto model for sequence classification, auto model for masked LM, auto model for casual LM, auto model for image classification, etc. Then functionality. Models take tokenized inputs, usually numerical IDs, and produce outputs like logits, embeddings, or hidden states, depending on the task. Then we have tokenizers, auto tokenizer, pre-trained tokenizer. So the purpose is tokenizers are responsible for converting raw input such as text, audio. I didn't know that tokenizers are also used for audio and image pixels. I was assuming that they're only used for text. For some reason, I was assuming that they're only used for text. But I guess it kind of makes sense, right? Because the output of the tokenizer is what gets fed into the language model. So I guess this would be one way to make what do you call it? A vision language model. Right. Anyways, into numerical format embeddings that can be fed into a model. They also handle converting model outputs back into human readable format. Then, pre-trained tokenizer, the base class for all tokenizers, providing methods for encoding text to IDs, decoding IDs to text, handling special tokens, and managing vocabulary. Okay, auto tokenizer, similar to auto model, this class allows you to load the appropriate tokenizer for a given pre-trained model by its name. It automatically determines the correct tokenizer class and loads its vocabulary and rules. You know what I'm wondering? I'm wondering if uh, I would be able to use auto model even on models that don't have transformers support. Because usually, if a model is supported by the transformers library, it's listed like in when you open up the models page, because like each each model usually has what's called a model card, I believe, or a model checkpoint. Model card, let's say model card. Once you open up the model card, it's essentially like a README for that one model for that repo. It gives a bunch of like information regarding the model, various like tech information or even just general purpose information. Where was I going with this? Yeah, usually on that page, there's going to be a sort of button that shows you how to use the model. And under that, like when you click that, it expands a small window which shows you the different ways that this model can be used. And that is where you find out if the model is supported by Hugging Face transformers or not. Or usually, I think the button itself kind of gives away if the thing is supported by HF transformers, or I don't remember. It might be a mixture of the two, but generally, it's something along those lines. That is how you find out if a given model is actually supported by Hugging Face transformers. Now, what I want to do is, because it's being mentioned here that this thing, auto model, it kind of determines the appropriate. Uh, in the case of auto model, what is being determined? It's a very convenient class that allows you to load any model from the Hugging Face hub, Hugging Face model hub, by simply specifying the name. Yeah. So um, it automatically infers the correct model architecture, and there are specialized auto model classes for different tasks like so and so, so and so, so and so. So I want to see if I'm able to load one of the other models that is not explicitly supported by HF transformers using auto model in some way. Okay, anyways, auto tokenizer, similar to so and so. All right, functionality. Tokenization, it breaks down input into smaller units such as words, subwords, characters, vocabulary lookup, mapping tokens to numerical IDs, input formatting, adding special tokens, padding sequences to a uniform length, and generating attention masks. Okay, then we have configuration. Purpose. Configuration objects store all the hyperparameters and architecture details of a model. This includes things like the number of layers, hidden size, vocabulary size, activation functions, etc. Right. Pre-trained config, the base class for the for model configurations. Autoconfig automatically loads the configuration for a specified model, making it easy to inspect or modify model parameters before loading the model itself. Functionality ensures that when you load a pre-trained model, it's initialized with the exact architecture and settings it was trained with. You can also use configurations to build models from scratch with custom parameters. Okay, great. Then, oh, the trainer API. We never actually got to this point. I remember this. We never actually, well, no, not entirely true. We kind of explored this, but we never actually finished this. I should have said that. Yeah, we never actually finished the trainer API, because this gives you the opportunity to take this model that for which the architecture has already been defined and retrain it or fine tune it using their API, which is incredibly powerful, because this basically means that you don't have to define the model architecture yourself. The architecture has already been defined, and then you can either build upon the weights that it currently has, so you can then fine tune the model, or you can just retrain it and establish your own set of weights. Right. Next, pipelines. Pipeline purpose. The pipeline function provides a high-level, easy-to-use API for performing common tasks with models. It abstracts away the complexities of tokenization, model inference, and post-processing. This is what I was talking about initially. This is the high-level thing. And then the other stuff that we saw, those are for giving you more control. So you can either pick this or that. And usually if you're going for something quick, you would probably prefer this, unless you have like various types of customizations and mixing and matching and stuff that you need to do. You would usually go for this. It abstracts away the complexities of tokenization, model inference, and post-processing. Functionality: you just specify a task, example sentiment analysis, fill mask, text generation. I need to look into what fill mask is. Image classification and automatic speech recognition. That's basically speech to text. Well, I guess ASR could be used for other stuff as well, but it is definitely used in what we call speech to text. And optionally, a model, and optionally a model, and the pipeline handles everything. Oh, okay. So you specify a task and optionally a model, um, and the pipeline handles everything else. It's excellent for quick prototyping and deployment. Oh, sorry about that. Okay, where was I? It's excellent for quick prototyping and deployment. Great. Then the trainer API. Oh, good. There's like a high level workflow as well. Awesome. Awesome. Okay, right. The trainer API. Purpose. The trainer class is a high performance trainer and evaluation training and evaluation loop for fine tuning models on custom datasets. Wait, it just says fine tuning, or it's just for fine tuning? I thought it's also for training something from scratch, which, I mean, to be fair, a bunch of these models that we are using through HF transformers, they're not trained on small amounts of data. Um, I didn't take that into account. Generally, these models aren't really trained on small amounts of data. So, like, if you are training them, you're probably going to be using very beefy hardware. So that might be part of the reason um, why the trainer API doesn't do that. I wonder if it does though. Like, is it at all possible to do from scratch? Because, like, okay, the idea, as far as I know, with fine tuning, the idea is freezing a bunch of the layers that you don't want to affect and leave the other layers that you do want to affect unfrozen. And then I guess you can make changes, make other changes to like various um, um, I was about to say make changes to various parameters, but I guess it would be hyper parameters, not just the well, no, maybe you could change the parameters of the thing as well. Either way, I don't know. But yeah, this is from what I know, this is the idea behind fine tuning, or this is one way of fine tuning where you freeze a bunch of the layers that you don't want to touch and leave the ones that you do want to touch untouched or unfrozen, like you don't freeze them. And then you run your training process. And whenever, I guess, whenever the back propagation is done, or however, the training loss is then being converted into a change that can be applied to the weights, whatever that process is. Whenever that is done, it mainly only affects the layers that you left open, the layers that you left unfrozen, not the layers that you chose to freeze. Sorry, zoned out. Okay, functionality. Oh, wait, hold on. Um, right, the trainer class is a high performance training and evaluation loop for fine-tuning models on custom datasets. It handles many custom training complexities such as uh, distributed training, mixed precision training, logging, and checkpointing. I have no idea what any of those are. I guess I'll get to that once I move forward with my deep learning studies. Okay, functionality requires a model, a training data set, which is often loaded using the datasets library, evaluation metrics, and training arguments, which define training parameters like batch size, learning rate, and number of epochs. All right. Um, Wait, so the training arguments are basically hyperparameters. Isn't that right? Yeah, because the batch size, the learning rate, the number of epochs, these are all hyperparameters. They're like outside of the neural network. Okay, anyways, then high level workflow. Here's a typical flow for using the transformers library. For inference, using pipeline for simplicity, you import pipelines from transformers, instantiate a pipeline for your desired task. Example, classifier so and so. Pass the input data directly to the pipeline, and then receive the processed output. Okay, simple enough. For inference, more granular control, you import auto tokenizer and auto model, or a task specific auto model like auto model for casual LM. Sorry, zoned out. Holy shit! What is that voice crack? But yeah, sorry, I zoned out. Hold on, let me hydrate. Okay, right. So import auto tokenizer and auto model, or a task specific auto model like auto model for casual LM. Then load pre-trained tokenizer. Tokenizer equals so and so from pre-trained. Okay. Then load a pre-trained model. Model equals auto model from pre-trained. Okay. Um, did I say did I just say tree trained? No, I said pre-trained. Anyways, prepare your input. Right. So input for so and so, return tensors, perform inference. Okay, great. And then process the model outputs. Example, get logits, apply softmax, decode token IDs. Okay. Yeah, so this is if you want more control over what is going on. In some cases, I might want to do this actually. Yeah, yeah. In some cases, I might actually want to do this because there's this thing, right? Because like, okay, we have one long video, right? We generate the timestamps for that. That is just one thing, right? That is um, one inference cycle, one inference run, and that's it. We are done with that specific stage. We get the audio transcript, where we get the timestamps and the text that's being said at different timestamps. Great, awesome. That's one inference. But then for the second stage, where we want to feed this into some sort of model and get different types of outputs, I need to find a decent way to do that. Yeah, yeah. I'll need to find a proper way to, because that's gonna be returning a list of timestamps, which are start and end timestamps. That's gonna be returning start and end timestamps, which I'm then gonna use later on. So, oh yeah. Um, After getting the start and end timestamps, I would then need to also do further sort of processing to, sorry, I'm thinking of this and I'm not able to like describe it properly, but there's multiple stages that we have to go through, right? Once we get the start and end timestamps of, like, let's say 5 different clips, so we have 5 start timestamps and 5 end timestamps. This is telling us that, okay, these specific sections are interesting clips. Okay, great, awesome. We have those timestamps, right? We take those timestamps and then we have to feed each of those timestamps into another model to have that model analyze those specific, um, analyze the clips being made out of those specific timestamps. So there I'll have to figure out what exactly I want to analyze, because we have already analyzed the audio, right? Maybe the next, or actually it's not even the audio that's being analyzed there. I didn't take that into account. It's the transcript that's being analyzed. I could analyze the audio as well. That is a thing. I could analyze the audio, and I could get some information about what is going on. I could also analyze the video of that specific section and figure out, like, get some information about what's going on. And then based on that, I could determine whether this needs to be, anyways. Okay, I can figure this out later on. I'm gonna need like a shitload of computing power for this. Actually, no, you know what? I should find out. I should find out if I do need a shitload of computing power for this. Because, okay, one thing is clear to me. In order to set this entire thing up, I'm going to need to set it up in multiple stages. And I'm okay with that. As in, sorry, in order to set this up as multiple stages, I'm going to need each stage to be a separate process, because there's no way that I can load every single one of these models that I plan on using. There's no way that I can load every single one of those models along with their weights, and, not have my computer's entire memory just run out. So that's why I'm going to have to do it in stages. The first stage, the great thing is it's going to be a one-time thing. We're going to be running inference on the model once. So we can run through that in one process, and that's going to write its output to a file, and then it's going to close, and then the next stage is going to start, which is going to be a new process, and then that process is going to read from the file. Yeah, yeah. Dude, this is going to be an interesting project to work on. And I'm glad that I'm well versed with Python for this, because holy shit, um, having to do this in Rust would have been, it would have been a nightmare. Like, holy shit, dude. I'm glad that I'm well versed in Python for this, because there's a bunch of like stuff like, writing to a file, and um, pulling data from lists and constructing lists and all of that stuff, which is just so much more concise and so much simpler to set up in Python rather than Rust. You can do it in Rust as well, but you would be writing, you would be forced to write code according to the borrow checkers rules and the memory safety systems rules and stuff like that. And in Python, I can just write the thing however I want. Though, okay, this thing that I just mentioned, this thing about, having to load the model and then unload it, this, I feel like this would have been solved if I was doing it in Rust. Though, another complication is that Transformers is not supported on Rust. However, there is a different version of it called Candle, which is a Rust-based library, and they have implemented a bunch of the models that are currently supported in Hugging Face Transformers. They have implemented a bunch of these models in Candle as well. I don't know if they've implemented all of them, but they've implemented a bunch of them. But yeah, I think for now I'm just going to stick with this because it's nice and concise. It'll make it much easier for me to write a very long, complex program with concise code, because writing that same long, complex program with Rust code it's going to be very, very verbose. I don't want to deal with that. Right, next, fine tuning using the trainer. Prepare your data set, often using the datasets library. Load a tokenizer and a task specific model, example, auto model for sequence classification. Define a tokenization function to pre-process your dataset. Then create training arguments to define your training setup. Define a compute metrics function for evaluation. Initialize the training, just a second. Yeah, initialize the trainer with your model, training arguments, data sets, and compute metrics function, and then call trainer.train to start fine-tuning. This overview should give you a solid foundation to start experimenting with the Hugging Face Transformers library across various applications beyond just LLMs. All right, great, awesome. Now, there is something. Where did I store that file? I don't remember. Backup. Let's go to, okay, we are already in documents, right? I probably did not put it here. Let's go into Scratch stuff. Oh, actually, yeah, is it in Scratch stuff or is it in this? If it was here, I would see Auto Clipper. I don't see Auto Clipper here. I don't see Auto Clipper here either. Yeah, I don't think it's here. I probably stored it somewhere because I remember opening up that file in on this machine, but I don't know where I stored it. Probably not Kaggle. What about Learning DL? That's FCNN. No, that's not what I'm looking for. Uh, I mean, I could just copy that file over, or just copy the markdown over, and like right now I could. So scratch stuff, empty directory. Um, I have the thing right here. So let's open up NeoVim. This, I think it's in documents. Gemini explains. No. Okay, what all is under documents here? AutoClipper Gemini info dot text. That's not, no, that's not what I was, that is not what I was looking for. Wait, let me open this thing up in Yahtzee and see if I'm able to find, because I'm pretty sure I'd created the markdown version of this conversation. I exported the markdown version of this conversation somewhere. Okay, let's open up Scratch stuff and see. maybe the empty directory here has it. Gemini explains. Okay, okay, okay. Uh, okay, let's look at empty directory, auto clipper, Gemini info. There it is. Okay, yeah. So I'm gonna open this up in NeoVim. Man, earlier today, like shortly before I started the stream, I had a bit of a crisis in NeoVim. I was typing out a paragraph for something and I was a couple of sentences in, right? And I went back to the second sentence of the paragraph and I accidentally I hit something that caused a bunch of stuff to get deleted. I don't remember what the key combo was, but like I hit something that caused something to happen and I went to undo it. You just hit the U key to undo, right? What I didn't realize was that my caps lock was on. And so when I hit U, a different type of undo happened there. It wasn't just a regular undo. And that created like a whole mess for me. But yeah, that taught me that I need to be a little careful about, though, okay, the mess that I created, that it got further exacerbated because I kind of panicked and, or not even panicked, I just got impatient and I started hitting undo again and again a couple of times, but that same paragraph wouldn't come back, like the remainder of the paragraph wouldn't come back because I'd also hit, capital U, not just a lowercase u. And I didn't realize that at the time. But then when I had a conversation with Gemini, I explained the whole situation. Gemini said that, okay, this is what probably could have happened. And that makes sense because I did also mention the caps lock thing. That's when Gemini explained that, okay, capital U means something different than small u. And even if you do this the next time, it's not a lost cause. There are ways to get it back. Just don't panic and, start pressing a bunch of stuff, essentially overwriting the data that you could recover, because NeoVim has a bunch of registers in which it stores data, different types of data, and data that has been changed at different times, deleted at different times, data that's connected to the system's clipboard, data that's like different types of data. They have like it has like a bunch of registers which store this data. So you still have ways to recover that data if you make this mistake. They also have like an entire undo list. If you learn how to read that list, then you could properly recover this mistake. But I mean, in this case, it wasn't like a massive loss for me. It was just, yeah, it was a fuck up. It happened. Anyways, let's open this up. Shit, I can't remember where I stored that. I could have sworn that I stored it somewhere on that machine because I remember opening it up in Frogmouth, and I wouldn't have been able to open it up in Frogmouth if I hadn't stored it in a markdown file. So I have like no idea. But anyways, let me yank this entire thing and come here. Scratch stuff. No, no. Um, yeah, dude, I'm confused about this. Should I check in another place? Let's do it in work. Yeah, it's probably not here either. Yeah, never mind. So here's what I'm gonna do. Okay, because I don't trust the copy function to do its job properly. What I'm gonna do is open this up like this. Uh, auto clipper Gemini info.md. Actually, I could store this into documents. Uh, whatever. Okay. Let's just store it here. Okay, that is done. And then let's open up Frogmouth. And our information should be here. Yeah, I've been doing a lot of data science and deep learning, so and so, so and so, so and so. Okay, you're looking into a fascinating application of AI for so and so. Yeah, okay. So I'm gonna transition back. Okay, great. Now, so this was the first thing, and then I did ask for a second thing. Wait, you said to convert so and so, but then it's just one big blob of text, is it not? Oh yeah, this is where it was explaining transcripts, like how the transcript is presented. I didn't realize it was presented like this, and that's actually really useful. Um, okay, could you go over all of it again, but in more detail? I believe this is where we get the entire information. Yes, this is where we get the entire information. So let's go from the beginning. Okay, your ultimate goal is to process a Twitch VOD and automatically identify timestamps corresponding to informative, funny, memorable, or interesting moments. For each identified timestamp, you want to analyze the subsequent 60 seconds to, well, I can set like a, length for um, how much I want to analyze and how much I want to produce out of that analysis. Like, well, yeah, I could directly analyze. Actually, no, I'm not going to be determining the timestamps. I'm going to feed this into an LLM and ask the LLM to analyze that whole thing and tell me which timestamps it finds interesting. I need to see if there are language models dedicated to analyzing transcripts specifically, or do I have to feed this into a large language model and give it specific instructions? Because I would have tried the Gemini route, but at this point in time, I don't think I can do that because they are under heavy load right now, and so a lot of the freebies that we were getting previously, they've kind of shrunk, let's say. A lot of the free stuff that we were getting API wise, um, that's been like reduced by quite a bit. So instead, I want to run it directly. Besides, like if, well, no, I won't have to send the. Anyways, running it locally is going to be much better. I have two options. One is run it locally. Another is create the entire setup such that I'm able to on run it in a Kaggle notebook instead. These are two approaches that I can take. The Kaggle notebook version is definitely not going to be local, that's for sure. However, it's going to be a lot more powerful, and additionally, I'll have access to GPU resources for it. So that's something. Right? I could also offload the heavier portions of the operation onto Kaggle and do the lighter versions of the operations locally. That's another possibility. Um, yeah, Kaggle does also have API that allows you to um, essentially upload and run a notebook and then receive the output from that run. But yeah, if I'm able to run these models locally, that would be just so much better. Even if I have to, because like, okay, I have one system that has 12 GB of RAM, so I could try running it on this system and see how that goes. Initially, I'm gonna have to go with like a smaller version of my VOD. I don't want to feed like a 2 hour VOD into it, I think I'll feed like a 5 minute clip or a 10 minute clip and tell it to find interesting stuff in there. And at least in that way, I'll be able to judge how much resource consumption there is from each of these models. And then I can decide like, how many different processes I want to like divide it up into. Because each of these models, like they are going to be a little on the heavier side. I could be wrong about that. To be fair, I could be wrong because I would have thought that even Kokoro TTS would have been super heavy, but then I was able to run like 4, 5 different instances of Kokoro TTS on one machine. I don't know if it was using the well, it might have been using the cached. Well, no, I don't remember. I don't remember what their method was for like downloading weights and stuff. But yeah, each time there was a new invocation. I had 4 or 5 separate shells, and in each shell I had activated the environment and I was running the script. So like these were separate processes. They were not the same process. They were not sharing the model in any way. They were all loading their own instance of the model and therefore also loading the weights again and again. And I didn't fill up the memory until like 4, 5, or 6 uh, instances of. Actually, I could have gone more. I think I could have gone more. I think the reason I stopped was because I was starting to notice lag in the response. Mainly, I was worried about how fast it responds, and that's why I had opened up those multiple instances. But I also discovered that, oh yeah, it's not all that heavy. It doesn't take up all that much space in memory. But yeah, okay. Right. I don't know how I got to that tangent, how I went on that entire tangent. And anyways, you want to analyze the subsequent 60 seconds to determine if the interesting content fits within that window. Then output these durations for clipping. Here's a detailed step-by-step pipeline. Video and audio pre-processing. Before any AI model can work its magic, you need to prepare the raw VOD. The purpose is extracting the raw audio stream. Where was I? Yeah, the purpose extract the raw audio stream and potentially downsample the video for more efficient for more efficient visual analysis. Then input your Twitch VOD, example an MP4, MOV, or MKV file. This is video. Okay, tools/libraries. FFmpeg is the industry standard for this. You'd use shell commands to extract the audio track. Optional downsample video frames. If your VOD is very high resolution or frame rate, you might extract frames at a lower rate. Example, 1 to 2 frames per second for faster computer vision processing. I should look into that. I didn't know that's a possibility with FFmpeg. How can FFmpeg downsample the video frames? How does that work? I should look into that as well. Yeah, I should definitely look into that. Um, Actually, yeah, hold on. I could ask this question in a new Gemini instance. Give me a second here. Okay, just a second. My system is slowing down a little bit. Okay, let's unload this and unload this, and we should be a bit better now. Yeah, better. Okay. What is going on here? Why is this so slow? Right. Load that up here. And then open up a new conversation. Okay. Right. There was a bit of an issue there. So, what was I gonna ask with the sudden lag? I just forgot. Okay. Yeah. Hey, so I'm gonna maybe the backstory is not necessary. Hey, so I'm wondering, um, if I'm gonna be feeding um, a video into an AI model for some kind of processing, I've been told that I can downsample the video and also reduce the frame rate using FFmpeg. Apparently, this gives better performance when using the AI model. What I'm wondering is, can FFmpeg really do that? And what are other options for pre-processing a video using FFmpeg if I'm gonna be feeding it as input to a model? Absolutely. FFmpeg is clearly the industry standard for, is actually the industry standard for this exact tool. Most AI pipelines, like those for object detection or action recognition, use FFmpeg behind the scenes because it's significantly faster and more memory efficient than decoding full resolution video um, directly in Python or C++. Downsampling is reducing the resolution and reducing downsampling, which is reducing the resolution and reducing the frame rate, are two of the most effective methods to speed up AI model inference without losing significant accuracy. How to downsample and reduce frame rate. You can do both in a single command using video filter, the VF flag. Okay, this downsamples the width to 640 pixels, and the negative one tells FFmpeg to automatically calculate the height to maintain the original aspect ratio. FPS equals 15 drops frames to reach exactly 15 frames per second. If your model only needs to see events and doesn't require smooth motion, okay, okay, okay. Now I get it. Okay, all right. Yeah, I definitely don't need like smooth motions. I can drop frames. I can drop frames. Lowering this will massively reduce the number of times your model has to run. Then other AI-specific pre-processing options. Beyond just size and speed, you can use FFmpeg to clean the data so the model sees only what matters. So there's cropping, then there's grayscale. If your model doesn't use color information like many thermal or edge detection models, converting to grayscale reduces the input data from 3 channels to one, saving memory. I should keep that in mind. Holy shit. Yes, I should keep that in mind. Then trimming. If you only need a specific segment, trim it before sending it to the model to avoid processing dead air. Okay? Normalization. You can adjust brightness or contrast if your video is too dark for the model to see properly. Combining everything. Okay, all right. Help me understand how FFmpeg is able to cleverly downsample the resolution. Wouldn't it need to guess what the pixel colors are supposed to be? Or, well, I shouldn't say guess, recalculate. My assumption is maybe it's using some sort of algorithm for that already, or maybe something like averaging colors around there. There has to be some sort of algorithm for that. Okay, this is a great insight. You're exactly right. Downsampling isn't just throwing away pixels. If you did that, the image would look blocky and jagged, an effect called aliasing. To do it cleverly, FFmpeg uses interpolation algorithms. Instead of just picking the nearest pixel, it looks at a neighborhood of pixels and calculates a new mathematically weighted color for the target pixel. How the clever math works. Nearest neighbor and so and so, so and so, so and so. Okay. Okay, all right. Oh, they have different sort of filters that can be applied, and each filter has a different um, effect, I should say. Like depending on what you're planning on using it for. Some work for motion detection, for example. Some work for like high precision, and some work for general AI inference. Okay, all right, cool. All right, you know what? I'm gonna continue. Hold on just a second. I'm gonna continue looking into, actually at this point, I don't need to just look into the Transformers library. I need to start using the library to do some of these things that I'm planning on doing. So I need to go back and read that entire like Auto Clipper Gemini info thing to get an idea of the kind of models that I'm looking for. Then I have to go look for the models, and then I have to find the models that I'm going to be able to run on my machine, and then finally run them. So this is going to take some time. This is probably going to be a very involved task. And that is why I'm glad that I'm doing it at the beginning of the year. We are like 4 days into the year, into this new year, and I'm already preparing this tool. Hopefully, hopefully we're going to be, hopefully this tool is going to be ready quick, or I'm gonna work on it iteratively and slowly start getting results out of it and then iteratively improve it over time. Um, that being said, Give me a second here. You know what? You know what? Yeah, I don't think I'm gonna raid anyone today. I think I'll just end right now, and I will hopefully stream again tomorrow. And hopefully we keep this stream going, this streak of multiple streams going. I know we missed 2 days, because of the new year, and then, well, I didn't stream the next day either because reasons. But before that, we had a decent streak going up all the way up until the end of the year. And now I'm hoping we are able to build up that streak again. Yeah, yeah. Okay, that's going to be it for